So in this short presentation, I'm going to address something that's very relevant for a lot of conventional companies, and that's this concept of separator shrinkage. And kind of the fun part of this whole story was it kind of all originated from an email we got from Dave Sorkelmo at ARC back in 2018, and it read something along these lines that we have rates that's measured at separated conditions, but we need to calculate what the stock tank rates are. And my team and I were constantly in this situation. Determining what our stock tank liquid volumes are, that's not trivial, and it's critical for translating our field estimates of production into stock tank volumes needed for Blackwell simulation model, or just declines for that matter. The fact that many wells are commingled in extensive field production gathering systems means that these fluids almost never reach stock tank conditions on a single well basis. And if you kind of want to summarize this problem that Dave had back then, and that many operators, especially working tight end conventionals, has, it's basically we need to convert separate oil and gas rates into standard conditions. So that means calculating the so-called oil shrinkage factor from separator to stock tank, and then calculating the total gas volume, so accounting from the gas coming out of solution of the separator oil. So in this presentation, what I'm going to do is I'm going to go through what is separator oil shrinkage and how can that be calculated in Watson Plus automatically for every single well where that's relevant to do. How we can do it in a bulk mode in the front end if you want to do that, or if you want to do it manually. So just a quick recap on separator oil shrinkage. So separator oil shrinkage is something that's maybe all of you know everything about already, but it's basically this point right here at the separator or a common tank battery or whatever. That's where we measure rates many times. The material balance from the well is 100% honored, while what we actually need to use in our declines, in our modeling work, etc., is stock tank rates, these guys over here. The difference can be severe. So, like when you talk about a GOR of a well, the so-called total GOR of the well is always much larger than the separator GOR. And the way you convert from the separator down to stock tank is to first account for the oil shrinkage factor, and then adding the flash factor. And those two parameters is what we quantify every single day automatically in Watson using an equation of state model. This thing right here is measured, and these two guys here is calculated. So this is kind of the key calculations that's going on when you upload production data to, for instance, Watson Plus, and when you want to convert those from separator to stock tank. So just a very quick recap from the separator down to, there might be several stages after, there might be an extensive pipeline network that you don't know the details of. So maybe you actually are forced to calculate what is actually happening downstream from that first stage separator. So you might be measuring the oil separator oil rate right here at the oil leg, and then there's actually gas coming out of solution and some residual oil that's left. And if you look at the separator oil at separated conditions, it's single phase, it's actually at its saturation pressure, and then as you go to a lower pressure, gas is liberated, and you're left with a smaller volume of oil, and that's called the shrunk oil or the stock tank oil in this case. And this there is some additional liberated gas that sometimes are sold, or sometimes it's flared, or even vented. The definition of separator oil shrinkage, that's just stock tank barrels over separator barrels, typically a number between 0.6 and 1. 0.6 would, of course, be a very large shrinkage, and 1 would be a no shrinkage. What this number is a function of fluid type, it's a function of separate temperatures and pressures, and this can, of course, change over time quite dramatically. The flash factor is the solution GOR of the separator oil. It's just scuffs per stock tank barrels, and it's the amount of gas that's actually in the separator oil when you measure it. And when you calculate these over time, this is just an example of separator oil shrinkage, they can actually change significantly. So they can start at 0.7, and then in this case there's days where you're above 0.8. So many times you'll like to capture this information, and this is just a same chart showing the flash factors as well. When it comes to Whitsun Plus, it's actually done automatically for you, and most of the clients we work with where this is really important is something that we automate through the so-called Whitsun Plus API. And this is already in production with a lot of Whitsun Plus clients. Happy to share references on that, but it's more important that you probably test it for yourself. You can also bulk run this in the front end. I'll give you an example of that, or manually input it in the front end. So with that, I'm just going to flip to the Arc front end right here, where we have a well where we initialized the PVT, and we've added production data. In this case, we have added separator rates. So we've added separator oil, gas, and water rates, and associated temperatures and pressures of the separator over time. Once I save here, automatically the software will go in and calculate the stock tank rate. So we'll do the conversion with an equation of state every single day for every single data point. And that's what's been going on here. So the rates that you're actually looking at here are actually calculated stock tank rates. That's what you're seeing right here. In the beginning here, there are some empty data points. And you can go to the Separator oil shrinkage tab, and you can actually see how your shrinkage factor is changing over time. So for this particular well, you can see that it's here up at 0.9, going down to 0.84, back up to 0.9 again. And you see also same with the flash factor. And this is done automatically for you. So then once you've done the shrinkage to stock tank, let's say you would like to go in and do decline curve analysis, you want to calculate bottom hole pressures, the flow material balance, whatever, you're using these shrunk volumes that's given to you at stock tank conditions, which is the ones you're supposed to use. That's the numbers you're actually using in the modeling work, in the decline curve analysis, or any other analysis consistently. So you're not using the separator oils, because using the separator oil volumes can be really dangerous in general. This you can do on a manual, well by well basis, or you can also go in here and select the wells you like to run it for, and you can run it for all the wells at the same time. If you're doing this through the API, which is what most people are doing every day, when you go into a particular well and you went to the production data, the rates would already be converted to a stock tank for you. So that was a little show and tell of how that process all work, and I've also attached a couple of papers associated to this. So actually what Dave, it's kind of started back in 2018, was a little research that we ended up writing a paper about that we presented at the IPTC 2020 down in Saudi Arabia. So looking forward to working with you all on this trial, and hopefully you can find this part of the software very valuable as well.